Hello, Assalamualaikum warahmatullahi wabarakatuh. In this video, me and my partner are going to explain about gas chromatography. So this is me and my partner. I am Muhammad Arif Fitri and my partner is Nur Hamiza Izati. So what is gas chromatography? To give you a brief introduction, GC or gas chromatography is a technique for separating components based on their volatilities or based on differences of boiling point. In GC, the components of a vaporized sample are separated as a result of being partitioned between a mobile gaseous phase and stationary liquid or a solid phase held in the column. The gas used is called carrier gas, and the typical carrier gas that were used in helium or nitrogen. The pressure from a compressed gas cylinder containing the carrier gas is sufficient to create the flow through the column. There are two types of gas chromatography. The first type is gas liquid chromatography, GLC, where the mobile phase is gas and the stationary phase is liquid. The second type is gas solid chromatography, GSC, where the mobile phase is also gas but the stationary phase is solid. The objective of gas chromatography are first to determine the retention times of N-butanol and 2-propanol. Second is to identify the components present in a standard mixture based on the retention times. Third, to determine the effect of temperature on TR and RS. Fourth is to identify the component present in the unknown sample. So here we have a block diagram of gas chromatography. So first we have a carrier gas, move to gas flow regulator, and then the sample is inserted through injector port, and then we have a column in the oven, detector, and then waste and computer and data analysis. So here we have the functions of the component in the gas chromatography. The carrier gas provides the mobile phase to carry the sample. Pressure regulator controls gas flow pressure into the system. Sample injector introduce and vaporize the sample. Column separate sample components. Oven controls column temperature. Detector detects and measure separated components. Data system records and analyze detector signal chromatography output. Vent or waste are to dispose of used gas and sample post-detection.
So this is the result from our chromatogram. Each compound has different retention time, like 2-propanol has 2.724, meanwhile N-butanol has 6.043. Standard mixture 1 has 2.692, standard mixture 2 has 3.294, standard mixture 3 has 2.225. So how we identify the peaks in an unknown gas chromatogram? To identify peaks in an unknown gas chromatogram, we compare their retention times with those of known standards run under identical conditions. Gas chromatography separates compounds based on volatility and polarity. More volatile or less polar compounds elute faster. Retention time is unique for each compound under fixed settings like temperature, flow rate, column type, and carrier gas. So consistent conditions are essential for accurate comparison. Lower boiling point compounds elute faster, while polar compounds may elute later if the stationary phase is also polar. Matching peaks to non-standards allows reliable identification of compounds in the sample. So this is our discussion. By increasing the column temperature in gas chromatography, it decreases the retention time of compounds by enhancing their volatility, allowing them to elute faster through the column. However, this can reduce peak resolution, especially for compounds with similar boiling points. They may elute too closely together. On the other hand, reducing the column temperature increases the retention time, to improving the separation between peaks and enhancing resolution. But it also limits the overall analysis time. Therefore, temperature must be carefully controlled or programmed to balance between faster elution and effective peak separation. Likely in our experiments, standard mixture 1 at 17 Celsius 2.692 seconds closely matches 2-propanol 2.724 seconds, indicating it likely highly contains 2-propanol. Standard mixture 200 Celsius 3.294 seconds shows a reduced retention time compared to N-butanol at 70 Celsius 6.043 seconds, suggesting it contains N-butanol which eluted faster due to higher temperature. Standard mixture 3140 Celsius 2.225 seconds eluted very quickly, indicating a highly volatile compounds such as methanol or ethanol. Thus, each standard mixture likely contains a single main component matching these retention behaviors.
So, in conclusion, the experiment demonstrates how column's temperature in gas chromatography significantly influence compound retention times and separation efficiency. Higher temperature reduce retention times by increasing compound volatility, but compromise peak resolution for similar compounds. By analyzing the retention times of standard mixture at different temperatures, it was concluded that standard mixture 1 likely contains 2-propanol, standard mixture 2 contains N-butanol, and standard mixture 3 contains a highly volatile compound such as methanol or ethanol. This confirms the importance of temperature control in accurately identifying and separating volatile organic compounds.